So, hi at all. I'm using a new platform here. So, first question, can you hear me? Ah, nice, okay. So, this is working. I have one more, let's say, little problem. I don't see the chat as expected via OBS because I'm a noob with OBS and I'm now using that tool. But I opened up a new browser window on the second screen and I can see the chat there. So I think this should not be a problem, and I have to do some more research on how to work with OBS for the next time. And then this will also work, I think so. So today I would like to show some stuff about AV Evasion, especially for C#. Second question, just to verify, last time the resolution was very high. I changed that to Full HD now. I think this should be okay from the size, right? So you can read it all. If no one complains, I think this should be okay. If you still can't read something, then I would need to change the settings or to scroll in. Yeah, the first thing I wanted to show is, or there are multiple things typically that are used, in my opinion, in C# or nearly in every language for pen testers and for red team people. And one thing is obviously all the tools that are publicly available. Another thing is shellcode injectors in some form. The third thing is PE loaders, and the fourth is basically any command and control agent or anything like that. I think this covers the most things that can or are done in C# today. And the plan is to at least show one or two tools and how to obfuscate them, or how to evade AV for those tools. Then the same thing for shellcode execution and for PE loading. But yeah, I have to admit, I don't know if the time slot is enough for all those things. So, and my VM seems to be very slow at the moment. Yeah, we will see how far we come. First thing I want to show you is the possibilities in general, or manual obfuscation, manual modification, let's say it like that. And just to get something to compare, I'd like to first of all build a seatbelt, which is, I think most of you should know a seatbelt. I think I don't have to explain this project or tool, but still I'm gonna drop a link into the chat when the browser's loading. It is very slow at the moment. patching AMSI and loading the assembly afterwards is one more way to evade antivirus. Oops. I can also show this. This was initially not the plan, because patching AMSI is, patching AMSI, you can load any binary afterwards if you patch AMSI. We can do this as well. Then I will do it after seatbelt. This was not my plan, but it's no problem. So seatbelt, just for that you all can read it up, is more or less a tool to get it's mostly reckon for the local system. So you can enumerate the system configuration, AMSI providers, auto-run entries. It can also enumerate credentials and extract credentials from various different software. And this is one tool that I think nearly all people in the community use every now and there, and therefore I choose seatbelt. Just to get a comparison for the to see how many engines detected this, we can drop a freshly compiled binary. No, not like that. To VirusTotal, just to get an overview how many vendors flag this, and afterwards we can do some modifications and use some obfuscators and recheck how many vendors detect the obfuscated or manually modified seatbelt. So at the moment I did nothing to this solution here. This is fresh compiled and it's directly from the GitHub repo. So this is without any modification, and as you can see, 38 security vendors flagged this file as malicious out of 68. I would have expected that more vendors flag seatbelt, but it looks like many of them don't even have a signature for this tool. So 38 flag it if we don't do any modification at all. I can check with thread check, and I will do that. But first of all, I want to show you at least the very first thing I do when I do modifications to evade AV signatures. And the first thing is, I showed this also in the last stream, is with Control, Shift and H, you can replace strings for a whole solution in Visual Studio. And we can say we replace, for example, seatbelt with the string totally legit. We can do this for the whole solution. This is more or less one of the easiest ways to change signature. In nearly all cases, if you want to obfuscate C# tools or a PE loader or a shellcode runner, you have to modify the source code, because all signatures are somehow flagging parts of the source code. One more thing. Last time I did talk about PowerShell, and PowerShell is a scripting language. Now, if we talk about C#, C# is not a scripting language at all, but it's a programming language. The difference is we can directly run any scripting language with native built-in Windows tools, and we can't do that with C# code, obviously. If we try to run C# source code, this won't work, so we have to compile the tool or whatever we're using, and this results in an executable. But the thing is that it's very easy to get the source code back for C# binaries if you have the compiled binary. So if you want to get the source code for a C# binary, you can just use a decompiler like, for example, ILSpy. ILSpy is one example. There's also AMSI. I'll drop this link here so that you can look this up. Yeah, and ILSpy is one decompiler for C# binaries, and it's really easy to get the source code for a C# binary if you just drop the compiled binary into, in this case, in this GUI here. I can just copy this here in this field, and afterwards I can get the whole source code for seatbelt back. And this is the reason that antivirus vendors tend to flag parts of the source code, because even if you compile the binary, then you can still get the source code back very easy, and you can therefore flag or build signatures for the source code, because the source code can be seen here as easy as I did this year. There are ways to run C# as scripts. Okay, maybe you know more than I know. I know that it's possible to run C# via MS-build, but this is, as far as I know, the source code is still compiled there. Roslyn is, yeah, I don't know much that much about Roslyn. I have to admit. So maybe this is possible, but I think that the most people compile their code and run the binary afterwards. Yeah, but as you can see, it's very easy to get the source code, and we can. I hope this is installed. It's not installed. Okay. We can also do this with an hex editor, for example. And I have to download this first, just to see. I think this is the correct one. So the most the AV vendors won't flag, or normally they won't decompile the C# binaries, but instead they build signatures for the hex values of the compiled executable. So if I just have to install this tool. I can also drop a link. And we will use ILSpy in the next like 30 or 40 minutes to analyze everything that is obfuscated, and just to see how effective some obfuscation tools are. and basically, or what they do, because not for every obfuscator there's source code available. So if I drop seatbelt into HXD, we'll have basically all the hex values for the tool, and we can still search for seatbelt. And as you can see, many parts of the source code and many parts are still visible in clear text for the here's are some libraries that are used or imported, but many parts of the source code are still visible if you just put the compiled C# executable in a hex editor. And therefore it's very easy to just flag strings like this one, or to just flag a string like seatbelt. If you have a seatbelt here with a GUID, you can build a signature for seatbelt with copyright from 2018 with the GUID, and then this is, for example, one signature, and this could be flagged. So this is very easy to build a signature. And yeah, as you saw here, I just replaced seatbelt with totally legit for the whole project. So every import is now, or every link for the other source code parts is now also totally legit instead of seatbelt. And just to get a first overview of how effective this one replacement for the whole solution is, I'll recompile and re-upload this to VirusTotal just to see how many vendors flag it in comparison to the solution with no modification at all. So we had 38 detections for the unmodified source code. Don't know why this is so slow. It was not that slow before starting the stream, but rebuild all started. Why does this take such a long time? It's ready. So we have a freshly compiled new executable, and we will drop this one to VirusTotal just to see the difference. And this was really a really easy modification, just to rename the main, or the name of the tool, which is used in many parts here, with another string. So just by doing this, we evaded 9 security vendors. It's 29 flag this as malicious now, and so this is 9 less vendors, but only doing this one modification. One more thing that I did show already in the last stream is that many or I did not do this test before, I have to say, but by modifying the GUID. I did read about vendors that flag tools by the GUID. So if we do some slight modification and just change the number values here, we can see how many vendors flag this GUID. Oh no, now it did compile really fast. So let's see. I think this is 4 more, oh no, 26, 29. So at least 3 vendors flag the binary only because of the GUID and or because of the tool's name. Maybe they have a signature for the tool name and the GUID. Yeah, it would be possible now to build a program like Hello World and give the Hello World program this GUID just to see how many vendors flag the binary only because of the GUID. But this is 3 less detections just by changing the GUID. Yeah, and now is the question, what else can they flag? Yeah, and that's basically everything that's in the source code. They can flag function names. They can flag the namespace name, but we already changed the namespace name here. It was seatbelt in the beginning. Now it's totally legit. The function names can still be flagged. Variable names can still be flagged. We have a variable here which is named SB. I don't think SB is a pretty good signature because this would result in many false positives if a vendor flags SB. This would not, this would have too many false positives. So I think this would not really be effective, or they would have many customers that complain because all other binaries are flagged and they are not malicious. So they have to build signatures for strings, for variable names, or for function names, or for other structs, for objects, whatever, which are very specific for this tool. So and here things like get event log reader or get event log reader in combination with other function names, these are examples that can be easily flagged. One more thing that is or can be easily flagged is every write host statement or every verbose statement, everything that is basically output by running the tool is many times flagged. So if you change all the write host statements and all the other statements, then you will evade many more vendors. But we don't want to do this manually because it will take a lot of time. It will take too much time, and we don't have that much time here. So and it doesn't make sense to go this way. So last time I already showed thread check and AMSI trigger. AMSI trigger is specific for PowerShell scripts and to detect the signature for PowerShell scripts. And thread check is written to detect signatures for basically only for Windows Defender, because it's using a binary, a Windows Defender specific binary. Manage settings, real-time predictions on, cloud protection is on. It's using a Windows binary from Defender to scan the it's splitting the binaries into chunks, and then it's scanning all the chunks with a binary under it's somewhere program files or something like that. In the last stream, I showed the part in the source code, and I also explained how thread check works and what the difference is to defender check. So I won't do this again now. You can watch the last stream, but if we want to get the signature for seatbelt in this case, we should be fine by running this command. Then seatbelt is splitted into multiple chunks, or the chunks, let's say I have to look up how many bytes the chunks are, but yeah, all the chunks are analyzed, and if one chunk returns malicious, then the signatures returned here. I had some strange behaviors last time that okay, there was already at least one signature, but I did not get the output here. This was the chunk, okay. Let's remove that. And then we are, yeah, this is really fucked up signature, okay. If we have a signature like that, the cloud protection is basically not relevant for this check, because only the real-time protection has to be enabled, but I still want to have the cloud protection on enabled. At least I want to have it enabled in the next step, because the cloud protection adds many more signatures for tools. So if you disable the cloud protection, you won't get a good result if it's not detected, because it can still be detected if cloud protection is on. If the target system has internet access, then all the maybe this is I had a one salesperson from McAfee in our company one time, and he told us that without their cloud protection, it's maybe only 0.5% of signatures, and if you enable cloud protection, then the other 99.5% signatures are added. So this is a really small part of the signatures, most likely. I think it's the same than with McAfee. And the cloud derivative protection adds so many more signatures because they are all in the cloud, and it's easy to just upload a file hash for a binary, check this file hash against the cloud, and return malicious or not malicious. So if you don't have this enabled, then most likely your binary is still flagged afterwards. Yeah, this really sucks. I don't like this signature because it's not really a signature. But okay, I won't use thread check again now here, because more and more I got false positives or signatures like this by using thread check. Yeah, we can just work with that, and I don't want to find all the signatures here manually now, and I don't want to change them manually, but instead I wanted to show you some obfuscation tools that are pretty good at automating the whole process for obfuscation. And the first thing, the first thing I want to show you is a list. I have to find the correct link. That's not it. That's it. So we're not going to do this all manually here. Offensivepipeline is a tool. I saw it on GitHub, and like 1 hour before the stream, I wanted to recheck this, and I was thinking about showing this or playing with this in the stream here. Can open one more tab. I think this is using ConfuserEx, right? This is using ConfuserEx. Yeah, it's using ConfuserEx. Maybe I'll show that at the end, or try that at the end. But I think all other things that I want to show already take so much time that we won't get to this part. But maybe maybe we will see. So this list has really many .NET obfuscation tools embedded, and I didn't test most of them because this would just take too much time, but I can show you the tools that I already used in this stream. They are here included as well, and just to get an overview how they work, what they do, and how good the results are for seatbelt, and maybe for another binary afterwards. So the first thing I want to show, last time for PowerShell I did show ISE steroids, which is commercial, or at least you can use it for 20 or 30 days, and afterwards the license expires. And I'm therefore also going to show one commercial tool here, which is Babel.net. And Babel.net is also in the list of obfuscators, and it's here. And I sent the link into the chat for Babel. That's this one. You can still, it's commercial, but you can still download a demo version and install the demo version. And if you do that, I did it before the stream just to save some time. You can start it, and it will look like this. The homepage says that the tool is really good and does this and that, and that the obfuscation is really nice and good. We will check this now. So if we drop seatbelt, into Babel, we will have some options here, and I have to say, just because this tool is so simple, and because it has the possibility to also obfuscate already compiled binaries, we also bought a license for this at work, because it's not expensive. It's like 100 or 150 bucks one time if you don't want to get updates. But yeah, it's possible to use this. I will choose encrypt our strings with XOR. You can also build or use a custom algorithm here. You can also encrypt values, resources, code. We can try to prevent disassembly with this tool. I'm going to generate a random seed here for the obfuscation. And all these fields here are obfuscated. This can also be done with the free version. The downside of the free version is that, or the demo version is that the generated binary expires after 20 or 30 days, and the obfuscated binary won't work afterwards. So you can only use it for like 30 days, and afterwards, if you want to start the binary, it will just break and say no, this or that function is not available anymore, and then it won't work. So if you don't buy a license, you can still use this obfuscated, and you can still use the binary that is generated for like 1 month or something like that. So and as you saw, I just clicked here on start obfuscation, and it returned an obfuscated binary in the Babel out folder. And now we can take a look. This the source code for Babel is not available as far as I know. It's not public. So we don't know how this obfuscation works, or we can't look it up. But we can decompile the binary after obfuscating it, just to see what Babel did to it. So the references are mostly the same. We had resources here. Just see or look it up. How resources looked in the... Oh, we didn't even have resources here in the normal seed belt. This time we have resources, but this is private. We can look into it. And we have many functions that have random names here. If we look into these, this, for example, is most likely, or was most likely, command DTO based. This is not obfuscated, so we can take a look in the seatbelt source code. Is this the same? I don't think so. That's not the best example. But it's not, as you can see, it's not as easy as it was before to find the source code here. But this is, you can still see that totally legit is the namespace name. You can still, the console write line statements are now XOR encrypted. It's not, XOR is not really an encryption. Every encryption uses XOR at some step or in the very last step, but yeah, this is XOR in this case, so every console write line statement is now obfuscated. But not every variable is obfuscated, not the function names are obfuscated. This is still a main function. This class name is still program. So not everything is changed. There are still good possibilities to build a signature for this obfuscated binary, because the variable names are still the same, or in many cases they are the same. The function names, if you flag this function names, they are still the same. So you can print logo. The logo is obfuscated now. That's also XOR. So if you have a signature for the logo, this will not work anymore. So this is basically really cool, that the write host statements and everything that is a string and that is outputted, that this is obfuscated. But there still is a way to, or there are still many ways to flag this binary. And therefore we will check the obfuscated binary to see how many vendors still detect this tool now. And one thing that you should not forget is retesting the binary after obfuscating it, because many obfuscators can break. Oh, there's no should help. So group all, no, I don't want to run all checks. We can run, for example, not all, but we can run, what can we run? We can run AMSI providers. So at least this function still works. Okay, we can group all. I can say that the most things will still work in this case. Yeah, it looks like that. Most things still work. So this binary is still usable. It's not broken by the obfuscation. And now we have, instead of 26 detections, we have 21 detections. And we can take a look if there are still detections for seatbelt. The other names are still somehow generic. It's all generic detections. Maybe, I can imagine that some vendors flag the Babel obfuscation. I think this will also return many false positives, but I think that many will still, or can do things like that. Or it's also possible to, that's one more way to enumerate this. The obfuscation is not the best. We have to say this is not the best. We have now, it was 28 detections before, and now it is 26, and now it's 21, so it's 5 more vendors. That's not really much in my opinion. So this can be done if you buy a license. You can also encrypt more values, but I would not say that the obfuscation of the tool gets much better by buying a license. So we only bought it because it's so easy, and if you need a quick obfuscation, then you can drop the binaries, click run, and in many cases you will still get rid of for McAfee this is fine, for Microsoft this is fine, for Sophos this is fine, Trend Micro this is fine. So this is it's still okay, or it's still good. What else is here? The same. Yeah, but Microsoft did flag it before. We obfuscated it with Babel. So Microsoft was one of the vendors that so that was evaded by Babel. We can check this out by dropping the binary in some not excluded folder, like for example the desktop. Okay. Oh. This is most likely then the cloud protection, I would assume. because here Microsoft did not pop up. It's undetected here, but it's still flagged if I drop it to the desktop. Defender Avast. I think that's most likely the cloud detection. So this was removed. Going to one more time, drop it to the folder, just to verify that it's the cloud detection in this case. That's strange. Uploading it to VirusTotal says that it's not flagged. Dropping it to the desktop, it's still flagged. But maybe now it's flagged because it was, the hash was already uploaded. Defender already got the return that this is malicious, and maybe it's still recognized as the same file and it's still deleted. I think that if I had cloud protection disabled before dropping the binary here, that it would not have get flagged. But yeah, we will just check other obfuscators to see if we can get rid of more vendors, and if we can get rid of the cloud protection as well. But this is pretty much so. Many of the variable names and of the function names are not obfuscated, and if you have a signature for that, it's easy to still catch the binary. So we'll check the next one. And the next one in my list is NET Obfuscate. No, I won't use this link. Yeah, initially I found this tool because this blog post was referenced in my AMSI PowerShell repository. I can see which referrers go to the repository and saw this blog post, and therefore I did take a look at it, and I think this obfuscator is really not bad. You can take a look at, or I'll drop the link. First I'll drop the link. You can take a look at the blog post at yourself, and we'll just run this obfuscator now to see how many vendors we evade with it. Stream C# obfuscators. Release folder. So NET Obfuscate. Prepared the NET Obfuscate. You can run -h to see how to use it. I can use --infile to take the path to seatbelt. Out file. Oh, this is not the full path. So this is the obfuscation process. And this tool definitely also renames all function names, all variable names. It replaces basically almost everything. And we can take a look at the obfuscated version, which is now around about 150 bytes bigger than the initial one. First, we check if it still runs. I did not test this before, so I cannot tell you if this still runs. I did test it with AMSI trigger, and AMSI trigger was obfuscated correctly and also ran afterwards. This looks like seatbelt is broken by the obfuscation. Bad. Set seatbelt. Seatbelt X. Let's just take a look if maybe the argument parser or somehow something like that is broken. AMSI provider. Nope. So this is broken. So this is maybe a 50-50% chance that this obfuscator works and gives you a correctly working binary back. But just to show you that this is more or less one time or 50-50 chance, whatever. I'm gonna still obfuscate AMSI trigger in this case. I won't dig into this error now. I don't want to find out what is wrong in this function and why dispose is not found anymore. This would take too much time. I would use this obfuscator as an either it works or it doesn't work. And yeah, now for AMSI trigger, I have AMSI trigger lying in the directory C stream, and AMSI trigger obfs.exe is the obfuscated AMSI trigger now. So we can take a look at the obfuscation if we drop AMSI trigger obfs into ILSpy. And as you can see, the variables are still not obfuscated. My fault. Variables are still not obfuscated in this case. But function names are obfuscated. So function names are renamed. Variables are still have the old value. I don't know about parameters. Parameter names, I think they are also obfuscated. Console write line statements are just base64 encoded, so base64 encoding is also not the best way to evade signatures here. It's much better to use XOR like Babel does for this part here, because base64 encoding it's just too simple to build a signature for a base64 string. It's really simple to, if you have a signature for Mimikatz is a bad example because it's not C# here. If you have a signature for sharpcuts, for example, then you can just flag the base64 string from sharpcuts as well, and this obfuscation is easily broken then. But I still like this tool because it already does more at the one and or other part than Babel. And I also like the blog post, how it's described, and in this case, we can test this now. Stream AMSI trigger ops. This is not broken at all. So we can say input file is stream PowerShell. Don't know if I have an example here. Yeah. At least this still works. It's not broken, so that's a 50-50 chance. You can test this. I would say obfuscating the function names is at least better than not doing it. So this is one more upgrade in comparison to Babel. And I would still like to upload this binary to VirusTotal just to check if the obfuscation was better in terms of signature detections to Babel. So you can hacking tool seatbelt. All these hacking tool seatbelt messages were not included in the Babel obfuscated seatbelt version. So I'm pretty sure that these hacking tool seatbelt detections come from the base 64 encoded write host statements. No, it's not write host, it's console write line. This is a detection for the base 64 part, I'm pretty sure. But this obfuscator seems to be better in terms of signatures and in terms of signature evasion than Babel, because it's only 13 detections on VirusTotal. Yeah, you wrote I shall not upload it to VirusTotal, but in this case I don't want to build a binary that cannot be detected by all vendors afterwards. I just want to get a comparison here, and it's really much not relevant if they are flagged afterwards, because I will show you at least one more tool that builds a new signature for every binary. So it's pretty much yeah, I don't know the right word in English. We don't have to care about it if they flag it, because there's one more tool that I'm going to show that that builds a new signature for every binary, and even if one is flagged, and even if they flag one of it, you can build a new one, and the next one won't be flagged because it's new signature. So this is better than the Babel obfuscator. I'm pretty sure, or I think, I cannot verify it in this short time, but I think that this is due to the function renaming. So many of the this was 21, this was Babel, this 13, so it's 7, 8. The 8, I think that the 8 vendor difference here is they flag functions or function names from seatbelt. This is an assumption, I don't know it for sure. So I'm gonna close Babel now. I showed you this one. So I'm gonna close this now as well. And in the next step, we're gonna take a look at Rosfuscator. Shelter. When asked about Shelter, Shelter is, as far as I know, a tool to include shellcode in a binary. So this is not what I want to show here. I'm showing in this stream, I'm going to show C# obfuscation and C# AV Evasion. And Shelter is basically a tool to include shellcode in an existing binary in a I don't know if it's the right word, canary, some part of the binary that where still place is, and you can include the shellcode there, make a jump to the shellcode, and then the binary still works, and the shellcode is executed in the background. That's not what I want to show here, but yes, I did use it in the past, and the shelter generated binaries were still flagged. So I did not found this to be very effective in terms of AV evasion. Okay, Rosfuscator. First, like all the other times, I'll drop the link. This is Rosfuscator. And the cool thing, I think this is really cool because Flunkwick did build this tool in like 4 Twitch streams, and each one is 1.5 hour long. So if you can build an obfuscator in such a short time, it's and if it's still good, that's awesome. And we will now verify or see how good the obfuscation of Rosfuscator is. I have to admit I didn't watch his 4 streams because I'm just not the watching videos is mostly not my learning field, or I'm not learning by watching videos. I'm more the blog post reader, but in this case I found the project so interesting that I tested it and I took a little look at the code, and I think this is really cool, so I'm gonna show it here. Oh, this is wrong. Obfuscators, Rosfuscator. So the usage for Rosfuscator is pretty simple. You just have to pass the path to a Visual Studio project file to, now I think it was not 4 hours, but it was 4 streams with 1.5 hour per stream, and I'm pretty sure that he's also spent time in between, but I didn't watch the stream, so it's this also is an assumption. I don't know it for sure. But this is a really cool project. I did make a copy from the seatbelt project because, or from the folder, because Rosfuscator works by obfuscating the source code and not the binary. So all other tools I showed before obfuscate the binary, but this one doesn't obfuscate the binary but the source code, and it does not output the obfuscated code in a separate path. So if I obfuscate seatbelt, then I don't have the original source code anymore, because everything in this folder will be obfuscated by Rosfuscator. And this will now take a little while. So we have to wait for a moment. But we can see everything that is encrypted. I think these are hash values generated for each. I don't know it. I didn't watch the stream, sorry, but obfuscation is still pretty good. I did test Rosfuscator already now for several tools, and I have to say that this also is not a this can also break the functionality of the program. Most of the time, when I obfuscated the binary with Rosfuscator, I had to manually adjust the source code afterwards to fix some errors which were generated by the obfuscation. But in the most cases, it's pretty simple to still get the source code working afterwards. So, and it is worth it because the obfuscation is the best that at least I tested so far. And this in such a short time, this is incredible. I don't know if Shelter has a commercial version. If yes, then I didn't test this one. I only tested the free one, if there is a commercial. Oops. Also, they are actively maintaining this tool. August 21. I did test Shelter. Well, this was 2 or 3 years ago, so maybe it did get much better in the meantime. I tested this 2 or 3 years ago and found it not to be very effective. But maybe it got much more effective now. I don't know. Would need to retest. But testing all binaries and testing all obfuscators is just too time consuming. I did show the link in the very beginning with all the .NET obfuscators. If you want to test all of them, this will take many days. But if you find one that fits your needs, then you should be fine. So the obfuscation of Rosfuscator was successful here, and I just open up our newly generated seatbelt project with the obfuscated code. And I'm gonna close some windows because everything is very slow here. I think I have to upgrade my hardware from time to time to get rid of this. End process, yes, I hope this is not the obfuscated version, but the other one. Uploading project. this also went into an error now. Close. What's up? So, one more try. Just because this seems to take some while in the moment. I'm also gonna obfuscate my, oh no, this call AMSI-ScanBuffer bypass GitHub. I did publish this call version of Rastermouse's AMSI-ScanBuffer bypass maybe 1 month or 2 months ago, and also gonna drop the link here, and I'm gonna show you how to obfuscate this one using Rosfuscator. Because this AMSI bypass is written in C#, and it's also, or it was flagged 1 or 2 days after publishing it. So if you have an AMSI bypass that is flagged by AMSI, it's pretty useless. So you have to change or obfuscate this repository or the source code as well to get it working again. This can be done manually. I know where the signatures are, but I still want to show you how to do it with Rosfuscator in this time, because yeah, that's part of this stream series here. So now I opened up the obfuscated seatbelt, and it's still loading. But no. We can take a look, and we see that the namespace name is not changed. The class names are changed. So if you didn't replace seatbelt in the very beginning with another name, then it would be really easy to still flag Rosfuscator obfuscated binaries by just flagging the namespace name, because seatbelt would still exist in every solution that you obfuscated via Rosfuscator. But most of the other things are obfuscated pretty good here. I think it's only the options, the argument parser for the options that's not obfuscated or looks like this. All right host statements, and I think this is the banner, are also XOR encoded. And Rosfuscator is making heavy use of XOR from what I read. So seatbelt would still exist as a string if we didn't replace that, but most of the other signatures are not available here anymore, because yeah, if you take a look at this code and if you compare it to the code from the very beginning, the exceptions are not obfuscated in this case. but we're gonna build this obfuscated seatbelt version now, just to see, or just to get a comparison on how effective this was. And we will also again test if the binary still works, because it can always be that it's broken by the obfuscator. This is the wrong folder. Seatbelt obfus. Oh no, it's the right one. Sorry, I did copy the binaries as well, but this is the obfuscated seatbelt. So this still works. It is the obfuscated one. We can check that because obfus seatbelt bin release. This was generated 6:05 p.m. 1 minute ago. So this is the Rosfuscator obfuscated binary. And it works. It looks like it still works. All, oh, no command, all. Oh, there's something broken. So it looks like not every function still works, because AMSI providers didn't work. There was an error for the function AMSI providers. Antivirus worked, app blocker worked, app table is broken, autoruns works, certificate, thumbprints works. Many functions still work, but not all of them. So we're gonna see how good this obfuscation is. I also didn't upload this obfuscated version before, so I don't know how this how the results are here. Oh, it's already more detections than the last time. So my assumption, or I said that this is, in my opinion, the best obfuscation. Looks like I was wrong, because there are still more signatures. 23 vendors flagged this obfuscated seatbelt version, and 13 flagged the .NET obfuscated binary. Yeah, now we would need to do something like thread check, or build a corresponding tool for other AV vendors to see the exact see the exact signature. Didn't I just copy this? Let's see. I also didn't rename this binary, but I don't think that the binary name is used for or as a signature. This would be very stupid to flag an executable just by its name. So we have to remove this one, because if we don't remove it, we will not get output here. PM. Seems like thread check's not working anymore as good as it did some time ago. Did work like a charm for me all the other times, but now it always returns nothing anymore. Did you face the same? Those of you who played with thread check? File as malicious but couldn't identify the bad binds. Yeah, that's bad. So we would need to maybe manually split this binary into chunks. It's 800, somehow 700 kilobytes, maybe 7 chunks at first, and see which of the chunks is flagged, and then analyze those chunks to see where the signature is. This is the manual way to find the last signatures. But I won't dive deeper into this here. I just wanted to show some obfuscators and to compare their effectiveness, which I did. And in general, it's possible to use an obfuscator to evade at least many antivirus vendors. But if it's a public obfuscator, it's also possible for the AV vendors to check how they work, to build signatures for exactly what they do, and to still flag them. In this case, there must be the key. I think it was something like the key in the function. Oh, the key. Yeah, Rosfuscator, for example, adds these function to the obfuscated program, and sometimes this function was also renamed, sometimes it wasn't, but you could also flag for this function some function with a random name, with an input byte, with a string, a variable input with the key string as name. If you flag this, or if you build a signature for this part, then you would get, or you would be able to flag all Rosfuscator obfuscated binaries, because this is embedded in every new binary. So either way, you would need to take a look at the obfuscator source code to take a look at how it works, and to make your own modifications, to use your own variable names, to modify it and to not make it public, because if you make something public, then it will get flagged sooner or later. If you don't make it public, it won't get flagged. So the best thing you can do is take one of the existing obfuscators, or building your own, or modify the existing obfuscators to get more stealth out of this. But yeah, this is one way. I also wanted to show you this CyscallAmsiScanBuffer bypass, and how this still works after using it with Rosfuscator. So, but that's this is the last thing, and then I can switch to, for example, using an AMSI bypass, patching AMSI, and loading a C# binary afterwards. Exclude the development. Yeah, I did exclude the path. If real-time protection is disabled, then thread check does not work anymore, because it cannot check binaries for signatures. If real-time protection is disabled, this won't work for sure. And excluding thread check itself results in false positive. I did also face that, but I didn't exclude thread check some minutes ago, but I did exclude ctemp file, the executable. That's the chunk of seatbelt, or one of the chunks, because I didn't want to Defender to flag, or I wanted Defender to remove this so that thread check thinks, okay, here's the signature, and that I get the output. Maybe this was a little bit confusing now because my English is not the best, but maybe some of you also did understand what I wanted to say. So, Syscall AMSIScanBuffer bypass. Did I paste the link? Yes, I did. This is basically nothing more or less than Rastermouse's AMSIScanBuffer patch, but instead of using pinvoke, I'm using deinvoke in this case to load, or to load the NT DLL functions, so the syscalls, to patch AMSIScanBuffer in memory. So in this case we are using syscall stub NT protect virtual memory as syscall. NT protect virtual memory. Afterwards we can use marshal copy to patch the bytes in the AMSIScanBuffer field, and afterwards we can use NT protect virtual memory again to clean up the permissions in memory. And this one is flagged. I don't know, library default is library, okay. Succeed. So now I'm going to show you that this syscall AMSIScanBuffer bypass is flagged by AMSI itself. Manage settings, cloud protection, we can do this on. Yeah, this is funny because the path to the binary contains AMSIScanBuffer, and therefore cannot go into this path because it's flagged by AMSI. So we're going to take the DLL. We're going to copy it to the C# directory. And afterwards, we're going to use import module. Nope, this still contains syscall AMSIScanBuffer bypass. Syscall bypass. Import minus module syscall bypass. The reason why I wrote this is that I had one EDR vendor that flagged the normal, which means Rastermouse's AMSIScanBuffer bypass, because I think it was flagged because it's using pinvoke. Should be it. And this bypass uses pinvoke, DLL import, kernel 32 get proc address, kernel 32 load library, kernel 32 virtual protect. And I think that the virtual protect was hooked by the EDR vendor, and that the vendor prevented me in this case from setting the protection to read, write, execute, and therefore I couldn't patch the AMSI-ScanBuffer bypass function. And this was the reason that I rewrote this, or I didn't rewrote it, but I used deinvoke to make the same with syscalls, and we can load this afterwards by simply providing the namespace name, the class name, patch by syscall, patch by syscall. I don't know if it's main. No, it's patch function. And in this case, it's not flagged anymore by AMSI, so I don't even need to obfuscate this. This is strange. I'm pretty sure that this was flagged 1 month ago. This is strange. Okay, it's not flagged anymore, so you don't need to modify this to bypass defender. I wonder about it, but this seems to still work, but other vendors will flag it, I'm pretty sure. Pretty sure that other vendors will flag it. So I'm still gonna show you the obfuscated version and how to make it usable again, because this one was normally broken every time when I obfuscated it via Rosfuscator. The patch bytes are not obfuscated here. This is also one thing that you can flag. The patch bytes for the AMSI-ScanBuffer function. If you just flag these bytes or this byte array, this is an easy way to catch this. So in this case, Rosfuscator added to the program class the function XOR-ANCDEC, or in the normal case, it adds XOR-ANCDEC to the program class, and in this case, it doesn't exist. So we have to, and that's the function that I told you in seatbelt. There's one function with which has something like the key as variable name. Oh, so in this, it's this function here. This is the newly added function by Rosfuscator. And we need this function to be reachable from every path or from every part of the code, so that, is it still in program? No, it's in devoke CS. We're gonna put this into program CS, into this class. That's okay for me. And so we have to get this working again, and I think this is pretty much the same process to get a binary working again, which was obfuscated with Rosfuscator. You need to replace the program XOR-ANC-decrypt function with the actual real function name, which is in this case this class, point this function name. So instead of using program XOR-ANCDEC, which doesn't exist anymore, we're going to rename this to this random string, point this random string. We do the same for this function, for this part of the script. It's the same case. It's program point this is replaced with the new function name. Replace all. So now we should have fixed most of the errors. If we rebuild this, we still have one error, and that is here. Something was broken in the function PE manual map. The good thing is that we don't need this function to make the Syscall bypass working, because this here is there's much dead code in this part of the repository, because I just copied nearly all deinvoke functions into one single file, and but we don't need all the functions. We only need getThisCallStub and all the functions that are referenced by getThisCallStub. So we don't need PE manual map, and we can either just comment out this or remove the whole function. Let's see if we can do that. This part. Pretty sure that we don't need the whole function. Pretty sure, but not 100%. Still failed. Because it was referenced. Okay, that was a fail. This function is still referenced in other functions. So I'm just going to comment out this part which was broken. And then we can see that this was successfully built. We have our Syscall bypass DLL, which is now obfuscated. Oh, wrong folder. This one. So it's 30 kilobytes more. We can verify that it's still working. Stream C#. Syscall bypass. Oops. The function names are not the same anymore. We have a namespace called patch. We have a class with this name, patch. Yeah, now the good question is, which of those functions is the patch function? We know that these are the patch bytes. So we can take a look which function takes these patch bytes. And this function here takes the patch bytes for 64-bit and for 32-bit. So we're going to use this function. And it's still working. So we bypassed AMSI via syscalls with an this time obfuscated C# syscall bypass. And now one of you asked me to show an example on patching AMSI and loading a C# binary afterwards. In this case, we did patch AMSI. So for this process, we can basically load any C# binary we want. And there are many examples where binaries are. Just gonna think about, yeah, we know that I won't load it from a web server in this case. can just paste this one into the chat, because this one is basically exactly doing what you said. The sharp loader is a PowerShell script that takes an AES encrypted compressed C# file from a remote web server, for example, like from GitHub, and patches AMSI at first, and after patching AMSI, it decrypts the C# binary. Oh no, first it loads it from the web server, then it decrypts, no, it base64 decodes the file, then it decrypts it, then it decompresses it, it's gzip compression, and then the assembly is loaded. Assembly load. So AMSI is patched, and afterwards the assembly is loaded. So this function does basically exactly what you were talking about. This is exactly the process. You can patch AMSI and afterwards load C#, any C# binary, which is really cool. But in this case, it's a PowerShell script. In the last stream, I did show ways on how to obfuscate PowerShell scripts. So if you didn't watch the last stream, I would recommend you now to take a look at it again, or to take a look at my blog posts about manual obfuscation for AMSI evasion, because this script is also flagged by AMSI. And if you bypass AMSI, then you can load Invoke Sharp Loader, and then you can use it as usual. So this is normally flagged. Yeah, it's flagged, so you need to bypass AMSI, and after you bypassed AMSI, which we did in this case, we did bypass AMSI here, so we can load Invoke Sharp Loader. And I also have some example binaries in this repository, encrypted C#. This is, for example, Rubius, internal monologue, grouper 2, seatbelt. We were using seatbelt the last times here, so I'm going to also load seatbelt in this case as an example. Invoke Sharp Loader, location is raw GitHub user content, encrypted C#, and the file is, I don't know if it's case sensitive. Seatbelt pen. We will see. The password is the same, and we will pass the argument. Oh, what argument do we pass? I don't know if it's the old AMSI version, the old seatbelt version or not. -h is not found, but this works. It downloads seatbelt from the URL. It decrypts that in memory, and afterwards the C# binary is executed. So you can do exactly this with Invoke Sharp Loader. There is another, or a C#, also from Flunkvik. He wrote NET Loader, which is basically exactly the same, but in C#. So if you're looking for a C# solution that does the same, or if you want to write a C# binary that patches AMSI and afterwards loads a binary from a web server, decrypts it, or no, this is without encryption. I think this is without encryption, but it loads a C# binary from a remote web server and patches AMSI before, and executes the C# binary afterwards. So, and Melvin did a lot of stuff here to evade the, to have a little bit fun with the AV vendors. But in one of the first commits, you can still take a look at the code and how it works. So it's still a new web client object. Then he has his own repository with the C# binaries. There's the AMSI-ScanBuffer patch. And then the binaries are loaded in a list. Then somewhere the AMSI-ScanBuffer patch should be executed. Most likely. Get a list of bins. I should take a look at main. This is main. Virtual protocol loading the binary. Invoke binary. And where's the patch? I don't see the binaries. Input little URL. Selected binary. Something went wrong. Invoke binary. Entry point invoke with arguments. Get bins. Patch AMSI. Patch AMSI. Okay. It's directly called here. If it's 64-bit, then AMSI is patched with these bytes. If it's 32 bits, it's patched with these bytes. And yeah, so in the very beginning, AMSI is patched, and afterwards the binaries are loaded. You would still need to obfuscate this one, or you can take a look at this, take a look at how it works, and afterwards you can build your own. If you build your own, you will have the best chances of evading any signature, and building your own binary is always the best way if you want to evade antivirus solutions. Just take a look at this code. This is a C# alternative. If you want to add encryption to NetLoader, it's not that hard, because you can, if you want to be lazy, you can just take my PowerShell script is also using C# in the background, so it's using add type to compile C# code at runtime, and so in my PowerShell script I'm also using C# to patch AMSI. I'm also using C# to load the binary, and I'm also using C# for the encryption, the gzip compression, and so on. So you can use this code to encrypt your binary with a custom password, and you can use the functions from Invoke Loader, ILSdecrypt, and decompress to decrypt it at runtime. And by encrypting and decrypting a binary, you will also evade signatures. For example, if the target environment uses a proxy, and if everything is forced to go through that proxy, then if you load a binary via web server, then it can still be cached, because the proxy can intercept, can analyze the binary, and can flag it. Even if you patched AMSI before, it's not relevant, because the proxy still sees the malicious binary and can still block it. So encryption is important to also evade a situation like that, because an encrypted binary, which is more or less, in this case, just in base64 encoded, gzip compressed, and encrypted binary, there is no signature for. If you use your own password, then it's not possible to build a signature for that. It's only possible to build a signature if you publish it. If you don't publish it, this string will never get flagged because you have your own password. Yeah, okay. Some AV have that. What do you mean with that? Decryption, the possibility to decrypt at runtime. I know that some vendors do that. Some vendors, for Microsoft Defender, for example, does this. If you have a binary that decrypts other payloads on runtime, then Defender analyzes every string in the source code or in the binary, and if Defender detects any base64 encoded string, then it will automatically try to decode that, to decompress that, and to also decrypt the payload with all the strings that it finds in the binary. I found this by testing some NIM payloads, because the NIM encrypted C# binary was still flagged by Defender on VirusTotal. I added a sleep, 90-second sleep, but it was still flagged because Defender, I think it must have analyzed the binary, found the key, and flagged this, because it was flagged after 5 seconds or something like that. So this cannot be due to the decrypted binary which was analyzed on runtime. I don't think so. But if you also encode or encrypt or XOR encode the key in your source code, then this detection also doesn't work anymore. So if you, that's if the key is in clear text, or if it's just base64 encoded, then it's easy to detect. But if you encrypt or encode the key itself and decode or decrypt it at runtime, then this also doesn't work anymore. And of course, for a sandbox or something like that, a sleep with a long time, 1, 2, 3 minutes, then the sandbox will never see the clear text payload. But I will do that in the NIM stream, which is there. It will take some weeks until I go for the NIM part. So that's basically the obfuscators. Everything I wanted to show regarding to obfuscators. And yeah, we also talked a little bit about patching AMSI and loading a binary afterwards. This is always possible, and this is even if the binary is not obfuscated at all, or even if you didn't do any modification to the source code, then you can still load the binary if you patched AMSI before. This is pretty simple. Then I have 2 more topics. I would like to show one more example for shellcode execution. And I'm gonna close all those VirusTotal results now, because this is more or less a little new chapter. We don't need the hex editor. We also don't need ILSpy. I think we don't need it anymore because I have source code for everything now. Close. Everything is slow. Oh, Offensivepipeline. Forgot about that. Offensivepipeline. Okay, I think I have all the dependencies, so this should not be a problem. I wanted to test this anyway, so if I do it in the stream or if I do it outside of the stream, it's not relevant. And if you don't want to see that, especially those of you who look this video afterwards, you can just skip the part, or if you already tested that. So we don't have all those dependencies installed. They are just not updated. I don't think that I need to update them in this case, because this is the version that the developer used. Okay. So this tool seems to download the GitHub repositories and obfuscate the code on runtime from the description. Obfuscate them via ConfuserEx and outputting them in my path or something like that. List all t tool name sharp up to output folder. Yes. I won't take a look at all the code now because this is a VM. I'm not afraid of this system getting compromised, so I can just test before taking a look at all the code. And if I run into an error or if something doesn't work, can still do some troubleshooting. So it's downloading the zip file, unzipping it. Yeah, but we can use ILSpy to check the obfuscation, and we can see, oh, it's a DLL. use a DLL here? No, he didn't use a DLL. I don't want to have a DLL. Then I want to have an executable console application. .NET Core. Oh, it's not an DLL. So I'm going to switch into this path. It's Offensivepipeline X. Is there? Help me. Didn't take a look. It is. So we can list the binaries that are available. Reviews, internal monologue, Inv0. We will take seatbelt in this case because we took seatbelt for all other tools as well. I think that's the tool is seatbelt. T is seatbelt. File not found. Oh shit. Build tools. I don't have all the dependencies. Don't know if this is the same path. Yeah, first I want to try it. I could add another tool afterwards. Common 7. So this folder doesn't exist in my case, but I have another folder. This one, vsdevcmd. vsdevcmd, and this exists. So if I replace this folder name with my folder name, this could or should work. I hope so. C stream C# Offensivepipeline main, Offensivepipeline main. What is this now? Output. Is the output folder generated? No, the output folder is not generated at all. Do I need to run this as administrator? MS build. Looks like seatbelt has not been downloaded here. Because the output folder is not generated. Get tools. Yeah, now I need to dig into the code, but this can take a while. dev tools. Let's take a look into the YAML file. Seatbelt. This should be correct. I think that the path for seatbelt is not correct anymore for the solution. Path is empty. Whee! Path is empty path. Just to try if it's seatbelt or if it's all of those tools. Cloning the repository Rubios, cloning the repository seatbelt. I think it was not cloned at all. Git tools Rubios, Rubios SLN. Git tools, empty. Does it delete them afterwards? Who of you tested this? I don't want to dig into the code now for too long. Did someone face the same error? Download repository, git tools, create directory, path, git tools. Git tools is created. Name, tool path, cloning repository tool name. If someone of you is a developer, this is not the good way for troubleshooting. I never learned programming from a developer's point of view, but this is my way of troubleshooting. So this is the git URL, this is the path, git tools Rubios. This is never created. Maybe we need the full path here. First time Obfuscator, now working when I've installed NET Desktop tools in Visual Studio. Also this last commit is there, that's shown here. Sometimes I had an error that by not using a full path user folder. But this seems to be not the issue here. But you know what? It clones the tool into this path, right? I can just clone it myself. Tool seatbelt SNN. Yeah, and it deletes them. Where is this file deleted? I also have .NET Core installed here. It's not .NET Framework. Download repository, build tool, execute command, RMD. I don't want to delete it. Wait, why should I delete it? Still deleted. Oh man. Created and deleted afterwards. I don't know. This takes too much time now, I think. I will take a look at it if I have some time afterwards. MS build access not recognized as an internal or external command. This looks like the real error. Do I need to execute this from a developer command line? Do I have MS build there? I don't want to have this. Pinned tools. Command line, developer command prompt. I don't have the environment variable set for. This could be the problem. So the error message was confusing, but Offensivepipeline seatbelt. Okay, this was the error. MS-build was not in the environment variable. So now looking at the log file can help. Output seatbelt, and we have an obfuscated seatbelt here. Oh, this looks good. Okay, I didn't give up. Stream C#. We will, no, not this one. We will open ILSpy, and we will take a look at this obfuscated executable. So looks like the namespace is not replaced. So we would need to still manually replace seatbelt with another namespace name if we want to evade signatures for the namespace. This looks like nothing at all is obfuscated. This also looks like no obfuscation at all for me. Where is the obfuscation? Seatbelt. Confused, sorry. This was the original seatbelt. This is the confused seatbelt. The assembly title is still seatbelt. I don't know if the GU ID is changed. Can't tell you. This looks more like an obfuscated bit decoder, decode. Bit decoder, bit tree decoder, decode, reverse decode, reverse decode. Okay. Nothing left from seatbelt. But so this looks like there's really nothing left from seatbelt itself. So it looks like it's ConfuserEx. I don't know how it works, but I would assume now from looking at the code that it this is the binary. This is the obfuscated binary, and ConfuserEx decodes this binary at runtime and starts it or loads it. If ConfuserEx loads this binary via assembly load, then this should still be flagged by AMSI. We could check that by going into this folder and running seatbelt. If nothing in the source code is changed, I would assume that when assembly load is run at this point, it's decrypted and afterwards it's loaded. I would assume that this should trigger an AMSI scan and that it should still be flagged, but it's not. It's not flagged. We can also take a look if this binary is flagged by AMSI, and we can upload it to VirusTotal too. But you could also combine all those other encryption methods, obfuscation methods, sorry, no encryption, but you can also obfuscate the source code via another obfuscator and afterwards use ConfuserEx to pack. This looks more or less like a packer for me, but I don't know how it works in the very end. Malicious PE. This is most likely everything that is most likely a signature, like everything that is packed via ConfuserEx is flagged. So it looks like 32 engines still flag this. So the antivirus vendors will know, I'm pretty sure now they will know how ConfuserEx works. They are able to decode the C# binary on runtime and they can still analyze it. So this looks like a not very effective way, and sincerely. This looks like it was 36 engines flagged the file without any modifications, and it's 32 with ConfuserEx. Yeah, it's worse than just renaming. So, but I think if you do obfuscation first and or manual replacement, and if you afterwards use ConfuserEx, then this can get much more effective, because maybe I don't know it, but maybe they will flag somehow flag the strings how they are embedded here. Yeah, I would need to test this, but ConfuserEx looks like this is not really a very solid obfuscation, not very effective. But I want to do one more test. I don't know. I have to look the command up every time because I don't have it in my mind on how to load a binary via system IO load read all bytes. This one. I just want to see if this confused binary is still flagged by AMSI. Maybe it's only the signature on disk that is still flagged by all these vendors, but maybe the AMSI part is not flagged anymore. Now the big question is, which function, is there any main function? Main. It's private, so I cannot call this directly. That's a problem. So we have to call the entry point. Sharp loader. Reflex system, point reflection, assembly, load, PE bytes. Oh, there's no AMSI trigger. So this works. We can bypass AMSI via ConfuserEx. Looks like we can do that. But we cannot evade signatures on disk. Now the big question is, how do we can do it like that. Entry point. Entry point invoke. Oh. Oh. Okay. Don't know how many arguments this needs to in the normal case. Method name. And null. Okay, I have to look something up. This is a colleague of mine, and he recently wrote a little script that can convert a C# binary to PowerShell and can afterwards load this. And this passes the arguments to, so you should generating a generic list, command, command is in this case -h, which doesn't exist for Rubius. Cannot explain and do it in parallel in this case. Past binding flags, reflection. Okay, this part. These are the binding flags. And then we need line 1. Assembly entry point. So we can basically set this main method to non-public static and invoke it via null. This is it. Private method invoke with null as the first argument and passed as the second argument. Let's try that. Null and passed, but without this part. Okay, this is normally the message that you get when AMSI triggers. So I don't know why. So AMSI seems to not trigger for loading the ConfuserEx binary, but AMSI triggers when the ConfuserEx binary is loaded and when ConfuserEx calls assembly load. This should be it. And this, so if we bypass AMSI now here, then we should be able to, but this is, I would not use ConfuserEx after doing this analysis. AMSI fail, why is the certificate not valid anymore? Uh-oh. Yeah, the certificate is not valid anymore. Have to send a message to Flangvik. So I'm gonna patch AMSI now just to be sure that this is like I think it is. So we will again call this and it works. Yeah, it's exactly like that. The ConfuserEx binary itself is not flagged by AMSI, but ConfuserEx calls assembly load and loads, so it decodes, decrypts whatever the binary on runtime and loads it, and this is flagged. So ConfuserEx is the worst thing you can do for obfuscation in this case. I'm sorry. So this is basically Offensivepipeline should use another obfuscator and not ConfuserEx to do this. Yeah. Now the stream is already 2 hours and 35 minutes. I'm going to do one more thing and then I'm going to quit, and I have to pass all the rest for the next stream. I think the shellcode part will be pretty fast. So closing all these. Disk. Oh. The disk is the main problem, or seems to be the main problem here. I should put my VM on an SSD now. I think it's still an HDD disk. So shellcode via pinvoke. Last thing for today. The question with VirusTotal, I already uploaded it to VirusTotal. It had only 3 less detections than the code which was not modified at all. Yeah, you could also do the stream. Encrypting or XOR or mathematic operations is exactly one thing to do to evade or to get shellcode execution working right. But there's still more. Yeah, so I have an code here from this link. I just copy pasted it and changed the shellcode. It's basically a pretty vanilla pinvoke create remote thread shellcode injection POC, and it's using open process, get module handle, get proc address, virtual unlock X, write process memory, and create remote thread to first we can enter a process name, then the process name or the ID is looked up for the process name with get process by name. Then the process ID or the process we target is opened via open process. Afterwards we allocate memory and set the permission for this memory region to read, write, execute. We write our shellcode into the remote process memory, which we allocated before, and afterwards we can just call create remote thread with the location for our shellcode to execute it. That's more or less what happens here. And we can do that as example. This folder is excluded, so or the whole stream folder is excluded, so this is not deleted at the very beginning. Oops. We can open up a process in which we have write access and say shellcode into notepad exe. Oh, notepad, not notepad exe. And as we can see, nothing happens, nothing seems to happen. But our calculator here is spawned. So this shellcode was basically just an MSF Venom payload, Windows x64 exec for calc, and this worked. Normally, I would assume now that Defender triggers and that Defender kills the Notepad process, and it did I just kill the Notepad process, or did Defender do this? I'll recheck. Ah, okay. Defender killed the Notepad process because Defender saw this shellcode in the Notepad process, and therefore it killed it because it said, well, this is malicious, this is MSF Venom generated shellcode, and therefore the process was killed. The funny thing is the code was still executed, so if we create a new process with our shellcode, the new process is still alive, but the old process is killed and there is a detection. This detection is not related to the signature on disk for this shellcode loader. I will do two more things before I explain why this Notepad process was killed and how Defender detected it, if you don't know it already. I will do two more things before. At first, I will upload this calculator shellcode to VirusTotal just to see how many vendors flag it, and afterwards I'm gonna delete the shellcode or replace it just with one null byte and recompile this. So we can see, by doing this, we can see how many vendors flag the shellcode itself. So this does not contain any malicious shellcode at all. And if we this is not malicious at all, so this whole script is not malicious at all anymore. Opening a calculator is also not malicious, but let's see how many. This was detected by 25 vendors, and the detection in the most cases, the detection is specific to Metasploit because it's generated with MSF-Venom. So they all, we will see if they all know, not all of them, but most of them flag this file. 25 flag them with shellcode, and 9 flag the file if you don't have shellcode in it. So these 9 flag this binary only, most likely, because it's using open process, virtual allocx, write process memory, and create remote thread, which is most likely shellcode injection related. We could also, just to be sure that it's not somehow on detection, comments are normally removed in the compilation process, so we can leave the comments. But so if we re-upload this, there should also not be any detection for a string from this POC, because this was public. But only from these two we can be pretty sure that the most detections come from the shellcode, and not for the file on disk at least, come from the shellcode and not from the rest of the program. So I re-add the shellcode here, and I also laid down the shellcode as a binary file here, calculator.bin, and one of you already told it. The main thing, it seems like it's 3 less detections when removing the console write line statements. So 3 of them flagged it because of injection success. Sophos, EZ also, so I'm gonna remove them just to be sure that these vendors don't flag it by the console write statements. So one way to get rid of all these signatures here, or of all these detections, is to encrypt the shellcode, like Stealth Hacker already said. And we can, to do this, we can, for example, use sharp encrypt again to encrypt our shellcode. C# shellcode. file we want to encrypt. Our calculator binary, and the password in this case is secure. The out file is okay. Password secure out file. Okay, this worked. So we have now an encrypted shellcode here, and if we want to decrypt this shellcode on runtime, we can, as I told you in the last, well, I don't know when, somewhere in the last hour or something like that, we can use the code from Invoke Sharploader to decrypt this encrypted shellcode on runtime. Decrypt base64 decode. So we can just use this. We have to change this, and we have to decrypt afterwards, and we don't have to put it in this location, but instead into the class. This looks better. So now we're gonna, just to verify that this shellcode still works, okay, I have to admit I'm too stupid. So C# file bytes from file. System.io read all bytes from, okay, system.io read all. System.io. If you're unable to read bytes from a file, read all bytes, file, convert method. I think it's easier because this is base64 encoded, so I can just use this as string, and yeah. Sorry for my noobishness. I can use this as string, and afterwards I can enc shellcode decode, decompress, password bytes decrypted. This is the part to decrypt. Don't have all this in my head, it's easier to copy paste sometimes. So we are decoding enc shellcode, we are decompressing this. We have a password which is secure, and we use this password to compute a hash. with this hash, the decompressed bytes are decrypted, and we will receive the original bytes back. We should receive the original bytes back. So this should be enough and should work to... We don't need this. We don't need this. And this is already included. And we don't need this because we're not downloading anything. So this is now generated. And let's see if this works. We again open up Notepad process and inject shellcode into this Notepad process, and it's decrypted on runtime, and the Notepad process is still killed, but this worked. So this is the next check. The shellcode is not clear text anymore. We can check if this binary with the encrypted shellcode is still flagged or not. So this was without any shellcode, and this was without shellcode and with all strings removed. And now with MSF Venom shellcode, which is decrypted on runtime, we have somewhere like 12 detections, which is half of the detection rate from the vanilla shellcode. So this is already pretty nice. It's okay. It's half of the vendors. So this is one way to evade signatures in this case. If we have the possibility to give the password on runtime, then we will most likely get less detections. So we can say something like args1 is the password. So the password is not included anymore in this binary. So we should get even less detections by doing this. But we would need to pass the password on runtime, and this also works. Just to see if this results in even less detections, I will re-upload this again. And the next step to evade that our target process is killed and to evade that the calculator itself is maybe killed afterwards is to replace pinvoke with deinvoke and or syscalls. And there already has been done pretty much, and there are many blog posts on how to this is exactly the same detection rate. So none of these detections here rely on the password being in the binary, and none of them seem to decrypt it at runtime. But so I think that most of these detections here will come from the imported libraries like cryptography, compression, interop services, plus the pinvoke libraries that are loaded, like OpenProcess, virtual allocx, write process memory, create remote thread. The combination of these is most likely, or I'm very sure that this is the case, that these vendors flag the binary because of this combination. And we can more or less get rid of this combination by using, for example, syscalls. And I wrote a blog post about many different techniques to do exactly this and to evade exactly this detection on the API level in this blog post. So when pinvoke is used, when the libraries are imported via the managed function from Microsoft via DLL import, then EDR vendors and antivirus vendors can inject their own code into the memory space of the executable that is loading these functions. They replace their own code with the very first thing that is done. So when my program calls create remote thread, for example, then the EDR and or AV vendors can say, okay, my code is executed at first. I want to analyze what we have in the memory, for example, and then they can analyze the start address, which I want to call, and they can on runtime see that at this start address in memory that the shellcode is there. And this technique from the EDR AV vendors is called hooking. So they hook these API calls to add their own code and to do an analysis before the function is called, and they can react if they see anything malicious in memory. That's basically the process of how they detect that. And in this case, I started Notepad, I injected into Notepad, and Defender will most likely have analyzed the start address. It will have seen that MSF Venom shellcode is there and will kill the process. So that's what is behind these detection, these runtime detection. And we don't have to reinvent the wheel. So first of all, I'm going to share if you want to do the same at home, wherever, then you can use this create remote thread POC and do the same thing for testing purposes. And if you want to use syscalls to evade this detection, then you can do it with this template, for example. It's using deinvoke, and it has not encrypted shellcode, so you need to do the same thing which I did for pinvoke here to also evade detections on disk because the shellcode is clear text here, or it's in byte array, which is clear text more or less. But this is using NT open process instead of open process. It's using NT allocate virtual memory instead of virtual alloc x. It's using NT write virtual memory instead of write process memory. And it's using NT create thread x instead of create remote thread. And these are the corresponding NT DLL functions and which are called from Windows itself. For example, if you call create remote thread, then Windows will in the background call NT create thread x. And these are the undocumented functions, and all undocumented functions from NTDLL are the so-called syscalls. Yeah, and you can use this template to evade the detection. I also put it in the chat, and I want to show this one time. Those 12 or 11 people here, if you really watched the whole 3 hours, you are tough. This takes so long to load. In the meantime, I can show you one more. Yeah, it's long, I know, but I didn't want to do one stream every week with 1 hour or 1.5 hours, but instead I want to do a whole topic more or less in one stream to so that the people can look it up afterwards. It will be uploaded to YouTube, for example, and the part that is interesting for you, you can look it up. I just wanted to not spend 1 hour per week, but instead 3 hours or something like that per stream for myself. Yeah, it's just my preference. But you don't need to watch the whole 3 hours because you can look it up in afterwards. Unhooker C# get rect, something like that. So one more way to, okay, this doesn't work. My stars. Unlock. So one more way to evade this is instead of using syscalls, is unhooking the functions. So I just said that the vendors hook these API calls in memory and add their own code, and it's possible for us, pen testers, red teamers, attackers, whatever, to unhook the same API calls on the same in memory. If the process is that we load the library from disk, for example NTDLL, we load it from disk, we copy exactly the content of NTDLL into our memory region where NTDLL is, and then by doing that we will remove the code that was added by the EDR or AV vendor. So we put a new clean copy of the DLL into memory, more or less, in a short explanation, and we will get rid of hooking by this technique as well. And I will just leave this as a message to the reader here to use, for example, this repository. It's I think it's the only C# repository for unhooking in the moment. You can use this code to unhook all the libraries in memory, and afterwards you can use the pinvoke API calls just as before, and there will be no detection because after your binary is executed, you will load a fresh copy of the DLLs, and therefore you will get rid of hooking. This has also an AMSI patch and an ATV patch included. We don't need that, so you can remove it. We don't need an ETV or an AMSI patch for shellcode execution. Only if our shellcode includes a .NET binary. But most times this is not the case. So this is this is for the reader. And the very last thing I'm gonna do is show how to, or that the detection is removed by using this codes. So we need to install deinvoke for this POC, and I want to build a release. This one takes the process ID as argument. So the process ID for our Notepad process is 14660, and we can say shellcode pinvoke 14660, and in this case it's a message box. The message box popped up. Notepad is not killed, so we evaded the detection on runtime, which occurred from using pinvoke by using deinvoke syscalls. This is not killed, this is not killed. This is the last thing that I wanted to show. Yeah, that's basically it for today. The next thing that I could show is how PE loaders work and how to make them not detectable anymore. But maybe I'll skip that and just show VBS the next time. So those few people which are left, do you have any questions or anything that I have to explain? Should explain? It's already getting dark in my room because there are many pixels. So if there are no questions, I will quit now and upload this to YouTube afterwards, so you can look it up if you want. And yeah, have a nice evening, or maybe it's not an evening wherever you are, but I'm out now and goodbye.